Okay, so the last topics we're going to talk about with complex numbers. The first is just substituting a complex number into a polynomial. So there's nothing especially different about how we do this. Just like we'd substitute if we had 3 plus x, we have 3 plus I, and we want to substitute into this function f of x. So everywhere there's an x, we're going to put a 3 plus I. So we get 3 plus I squared minus 5 times 3 plus I plus 2. And now it's just a matter of being careful and multiplying things out. So they kind of skipped this step, but 3 plus I times 3 plus I. Interestingly, I think they made a mistake. So this whole thing is what you're going to have to multiply by itself. So 3 plus I times 3 plus I is going to be 9 plus 3 plus I plus 3 plus I, which will be 6I plus I squared. So this is actually a 9, and they corrected it here, but it's incorrect there. And we multiply this 5, distribute this by both of those terms to get a minus 15 minus 5I plus 2. And now we just need to combine like terms, combine all the real parts and the imaginary parts to get minus 5 plus I. Okay, what if it looks like this? If we have a rational function instead? Same thing. Everywhere there's an x, we're going to put 10I. So this just has an imaginary part. So we get 2 plus 10I, 10I plus 3. All right, now we've got a division problem. So we rewrote this in standard form. We've got a division problem with a complex number in the denominator. Got to get rid of this complex number. I don't know how to divide by complex numbers. Okay, so we multiply by the complex conjugate in the numerator and denominator and multiply things out. You can look at that carefully. Combine like terms, or here I guess they just simplified the I squared. Combine like terms, you get a complex number in the numerator, a real number in the denominator. If you don't, you've done something wrong. And then you divide it into the real and the imaginary parts to get it in standard form. 106 over 109 plus 10 over 109 times I. All right, so the last thing to talk about is simplifying powers of I. So let's just think about what this would be. I to the first power is just going to be I. I squared is negative 1. What's I cubed? Well, it's going to be negative 1 times I, so negative I. How about this one, I to the fourth? It's going to be I squared times I squared, so negative 1 times negative 1, which would just be 1. And I to the fifth, we could think of as I to the fourth times I. Maybe I should have revealed this earlier. Right, so I to the first power is just I squared is negative 1. I cubed we can write as I squared times I, so that becomes negative I. I to the fourth is, we could think of that as I cubed times I, so negative I times I, negative I squared, negative negative 1, which is just positive 1. And then I to the fifth, we can write as I to the fourth times I, 1 times I, which is just I. And it's going to cycle through, it's cyclic. So then I to the sixth is going to be negative 1, I to the seventh is going to be negative I to the eighth is going to be 1, I to the ninth is going to be I. Okay, so the real question is, how many of these I to the fourths can we factor out of something? So how about like I to the sixth? Well, that's like I to the fourth, which is just 1, so we can ignore that. So it's really the same as I squared, so it's going to be negative 1. Sure enough. I to the seventh, well, we could think of that as I to the fourth with I cubed left over, so that's going to be negative 1, or negative I, sorry. I to the eighth, it's like I to the fourth times I to the fourth, 1 times 1, which is just 1. I to the ninth, we could take out I to the fourth, and just be left with I, right? So you can do two things. You can either remember these first 4 I powers, or you can always just figure them out, right? They're not that, I find it easier to just think through it rather than try to remember that I cubed is negative I. So what if we had like a really big number? Well, sort of big, like 35. How could we figure that out? Well, we could think of this as there's 8 times 4 is 32 plus 3, right? So all of these fourth powers, we could think of it like this: I to the fourth times 8, I to the fourth times 8. These are all just 1, right? I to the fourth is just 1. So we're just left with I cubed, which is negative I, right? So the easiest way to do these is to think, okay, what's the most times that 4 goes into this number? 32, so 8, so that's 32. So get rid of those. I'm just left with 3 left. I cubed is negative I. Does that make sense? This is just a table. There are different ways you could do this if you wanted to. You could think of, well, it's I squared to the 17th power. Well, that's negative 1 to the 17th, which would be negative I. Or you could think of it as 33 and 2. I squared is negative 1, right? I mean, this wouldn't really make sense. So anyway, the point of this table is there's different ways you can obviously factor things out, but the easiest way is to say, how many times does 4 go into it? 8 times. Okay, if that's 32, take away the 32, there's 3 left. So it's going to be I cubed. Does that make sense? Your homework will give you some extra practice. All right, and that is what we're going to do with complex numbers in this section.